Hello everyone and welcome back to Yamaya's learning sessions. I hope you had a very beautiful and blessed day. So today we're going to be working on a problem from Quest Homework number 11. This is problem 6. So this is what the problem says. Two concrete spans of 320 meters of a 320 meter long bridge are placed end to end so that no room is allowed for expansion. If the temperature increases by 20 degrees Celsius, what is the height to which the spans rise when they buckle? Assume the thermal coefficient of expansion is 1.2 times 10 to the negative fifth. It wants the answer in units of meters. Okie dokie. So, it gives us the final length, which is 320. It gives us the change in temperature, and the reason why it's a change in temperature and not just temperature is because it tells us that the temperature increases by 20 degrees Celsius. That means that the temperature has changed, so that's why it is a change in temperature. Then we have the thermal coefficient of expansion, which is 1.2 times 10 to the negative fifth, and I have right here, which you may not have in your T-chart, and you may be wondering, well, why do you have this? The initial length, okay? And you may be wondering why, okay? So I'm just going to erase some doodling I did over here. So it says that 320 is the length of the entire span of the bridge. But as you can see, when the temperature increases by 20 degrees Celsius, it wants us to find the height to which the spans rise when they buckle. So in the second image right here, you see how they are buckling. So you can see that they're kind of like separated into two. So we need to find that length of just one of these spans of the bridge, right? So right there. All you're going to do is take your final length and divide it by 2. So in my case, it's 320 divided by 2 is equal to 160 meters. Okay, you might have the same numbers as me, but you may have different numbers. It really depends. Okay, so come over here and look at this picture that I drew. Not the best, so I apologize. I'm not the most artsy person. Okay, but you see how the spans rise and they buckle, right? So you have this line down the middle right here. Then you have, change the color, the initial length, so just the length of one of the spans that goes that way. And we're trying to find here in the purple the height to which the spans rise when they buckle. This is what the problem is asking us to solve for. So the first equation we're going to be using is the equation for thermal expansion, which is the change in length is equal to the initial length times the thermal coefficient of expansion, which is alpha, right? Times the change in temperature, okay? So we need to find the change in length. So I like to do things in different colors. This is what we're looking for at the moment, okay? So it gives us everything we need. That way we can easily solve for the change in length, right? Okay. So, so 160 times 1.2 times 10 to the negative fifth, that was kind of ugly, times 20, which is our change in temperature. And that gives us the change in length is equal to 0.0384, okay? Now, we are going to get this new length. Now, what I mean by the new length, right? I'm just going to have to draw a little bit of a picture here again, okay? So we just found our change in length, right? So this is like the change in length is kind of like this. How did it change once these two spans from the bridge kind of collided and rose, right? So we have our initial length, And all we're going to do is take our change in length and add it to our initial length. So for me, 160 plus 0.0384 is going to give me at least 160.0384. Okay, so that is our new length. This is what we're going to be using to put into our next equation. Now, if you didn't already guess it, which maybe you should, maybe you shouldn't have, this diagram that I drew, it looks like a triangle, and it is a triangle. So guess what's coming back? Pythagorean theorem. We all love triangles, don't we? Okay, so I'm just going to do this in a little different color. We'll do this green. Greens are pretty these days. Okay, so Pythagorean theorem. A squared plus b squared equals c squared. Now you may be wondering, well, how do I know where to put my numbers, yada, yada, yada? Okay, well, good question. So we all know that if we're thinking about a triangle, this side should be the hypotenuse, right? And this side probably is the adjacent side, right? So when we're putting this into our equation, b squared is what we're going to be looking for. So this is what we're looking for, right? Do this in a different color. Okay. So we have a squared, which is 160, right? This side is 160, the hypotenuse side. So 160 squared plus b squared equals 160.0384 squared. So this is our c squared, our new length that we just found, right? Our change in length. Okay? Okay. So now I'm sure you can do this math on your own. I'm just going to walk you through it a little bit. So we have 25,600 when we square that plus b squared equals 25,612.2894. Oh, sorry, that's kind of cramped. Okay, now we need to isolate our variable. Do the inverse operation, subtract 25,600 from both sides. Okay, this cancels out. B squared is equal to 12.2894. Now, because it's b squared, we need to get rid of that. We're going to do the square root. I apologize for this handwriting. It is really not the best. B is equal to 3.5056. So this is, or you can say B or like height or even Y, but B really. So this is our final answer, my friends. Oh my goodness. My lines are not straight these days. Okay, there we go. Okay, so recap what we did real quick. We listed everything, all our information in our T-chart, so we can be a little bit more organized in that sense. We said, okay, we have the final length, the change in temperature, the thermal coefficient of expansion. And so then we figured out that we needed to find the initial length because we're going to plug it into the thermal expansion equation. We solved for the change in length, then we solved for the new length by adding change in length plus our initial length. Then we said, okay, this kind of looks like a triangle right here. We're trying to find the height to which the spans rise when they buckle. Then we said we're going to use Pythagorean theorem to find our b squared. So we put it all into the equation for Pythagorean theorem, and we found out that the height to which the spans rise when they buckle is 3.5056. You may have gotten a different answer. Of course, that would make sense because you have your numbers And I hope that helped you. And if you have any questions, comments, or concerns, please feel free to leave them in the comments below. I would love your feedback. Thank you so much for watching, and I hope this helped you. Bye-bye.